Chapter 5, Section 5, Data Aggregation. Imagine if you could summarize thousands of mesh records into just one simple report, instantly revealing where your company needs help. Sounds powerful, right? In this section, we will learn a key technique to do exactly that, data aggregation. In this section, you will discover how data aggregation simplifies complex data into clear insights, how it helps you quickly spot trends that drive better decisions, when and how to choose the right aggregation method for your business challenges. Think about your company's salary records. Instead of reviewing each employee one by one, wouldn't it be easier to know the average salary per team at a glance? This is exactly what data aggregation does. It summarizes multiple data points into simple, meaningful metrics, helping you see the bigger picture clearly. Data aggregation is the process of summarizing multiple data points into a single metric to provide meaningful insight at a higher level. For example, instead of analyzing individual employee records, we can summarize total or average values per department, count a number of employees per job role, calculate group-level statistics to compare trends across different categories. Aggregation helps convert raw data into actionable insights, making it easier for us to grasp patterns within data. Let's explore the advantage of aggregation using human resource analytics as an example. Human resource datasets, also called employee datasets, often contain individual-level data, which is useful, but decision-making happens at the group level. For example, we might ask, which departments have the highest overtime hours? What is the average employee satisfaction score per region? How do promotion rates vary by job level? By aggregating data, we reduce complexity and generate clear trends that drive our decision-making. Let's see some types of aggregation using an example of human resource analytics. First, aggregation is commonly used to summarize numeric columns such as mean salary per department, sum of overtime hours per team, middle value of performance scores per job role. Aggregation also helps count occurrences of categorical values such as number of employees per department, percentage of employees in remote versus office roles, and promotion count per job level. Sometimes we need to identify extremes such as highest performing department based on employee ratings and lowest average salary among job roles. Let's consider an HR dataset with employee data. This is an individual level data, meaning that each observation represents individual employees. By data aggregation, we can convert this dataset into group-level data, where each observation represents each department. By doing so, we can clearly see the similarities and differences between departments. Using this dataset, let's implement this data aggregation by Python. We can do that aggregation using this code. Let's explore this code in detail. First, let's focus on this part. The first line starts the aggregation process. df group by department groups the original dataset df by the values in the department column. Each group will then be processed separately using aggregation functions defined next. Let's see from line 2 to line 4. This dictionary specifies the aggregation rules for each column. The first, salary, mean, calculates the average salary for each department. The second, performance score, mean, calculates the average performance score for each department. The third, overtime hours, sum, calculates the total overtime hours for each department. The line 5 closes the aggregation method. Ag reset index turns the grouped column department back into a regular column instead of keeping it as an index, making the resulting data frame easier to work with. Let's go on to the next part. This part renames the columns of aggregated data frame to more readable labels. Specifically, it renames salary to average salary, performance score to average performance score, and overtime hours to total overtime hours. Then, let's display the resulting data frame. It shows the aggregated data grouped by department. Now, we can clearly see that IT employees have the highest salaries and performance scores. Sales employees have the highest total overtime hours. These insights help HR make strategic decisions on salary adjustments, workload balance, and performance incentives. Let's wrap up. Data aggregation simplifies individual data into meaningful group-level insights. Aggregation techniques help organizations make data-driven decisions. Thank you for watching. If you have any questions, feel free to ask in the comments. Your feedback is always appreciated.